The water issue I researched is the saltwater intrusion of the Gaza Strip, and I would say that this water problem is a combination of both water scarcity and water quality issues. As we can see here on this left side of the image, the coastal aquifer is an aquifer that's shared between three regions primarily. So Israel, Egypt, and the Gaza Strip. Both Israel and Egypt have other sources of water, whereas the Gaza Strip solely relies on the water that comes from this coastal aquifer. And the issues surrounding the aquifer aren't recent at all. In 1997, the World Bank described the water problems as an emergency state of affairs, and since then it's only gotten worse. The main factors that I would say are contributing to the issues, the saltwater intrusion and all of that, are the rapid population growth of the Gaza Strip, pollution of the groundwater, overpumping, and the conflict that there is with Israel. As we can see here, the yellow line represents the sustainable yield, which means that it's the amount that can safely be taken from the aquifer and still have the natural process of the recharge and everything to continue to supply water. But even in the 1990s, the extraction rate of water coming out of the aquifer was way higher, above the amount that can safely be taken out and not really have to worry about that. And it's grown since then, as we can see on the graph. Overpumping of the aquifer, so taking out the water to be able to drink it, use it for, whatever's needed to be used for. Overpumping has decreased the levels of groundwater by about between 10 to 20 meters over the last 4 decades. And as the groundwater levels decrease, it makes it easier for the salt water from the Mediterranean Sea to come in and infiltrate. It just seeps into the groundwater to kind of replenish what is being taken out. So on the left here, we have chloride concentration, and studying that allows people to monitor the quality of the aquifer in relationship to its salinity. So the World Health Organization determined that water that has chloride levels less than 250 milligrams per liter is considered safe for human consumption. So on this image, we see here the less than 250 is the dark green, which is not a lot in the Gaza Strip area. So it's just up here and then a little dot there and a little bit down here. Everything else is really not considered safe for human consumption. And the most that we see, I think, ranges between 2,000 and 10,000 milligrams per liter right here along the western edge. And that's caused from saltwater intrusion. Over here on the right side, we see the nitrate concentration, which pertains to water quality more than, or the pollution occurs from raw sewage and untreated wastewater that's infiltrated back into the aquifer system, which allow more opportunities for waterborne illnesses. So of course, people are going to be affected by that. And the lack of water or functioning water treatment facilities have resulted in about 90 million liters of untreated or even partially treated sewage to get back into the groundwater. And then, of course, that's being extracted again for human use. And once again, the World Health Organization determined that 50 milligrams per liter of the nitrate concentration is safe for water to be considered to be consumable, safe for consumption. And that's also the dark green areas, which is not the majority, just these little splotches that we see around here. And when you combine both the chloride concentrations and nitrate concentrations, when trying to figure out, how much water might be safe for consumption in the Gaza Strip, it's less than 4%. I think it's closer, approximated at 3.8% of the water there is safe for human consumption. There's been a blockade in place since 2007, which has prevented any materials from being imported that could help rebuild damaged infrastructure that could treat the wastewater and allow people to have more access to safer water. And now there's an issue of if there's a total contamination of this aquifer, which would basically be considered a collapse of it, where there's no water that's considered safe for human consumption. The water, of course, would need to come from an outside source, which would cost a lot of money, and it's estimated that it would be over $600 million to start replenishing all of the water and treatment facilities and all of that.